Okay. Then comes ozonation, using ozone gas to kill the organisms. Anyone seen this technology to used being used on ship? Ozonation apart from a ballast water anywhere else? Well, some of you may have seen there's an ozone generator in one of the cold rooms, especially the veg rooms. So basically, you have got this small box fitted on the top or on the side bulkhead, and basically it is written ozone generator on the side. We have got louvers here. So basically, it is generating ozone gas into the cold room to kill the bacteria. So that again is not a new technology. We know it is being used, so we can use it here as well. Okay. So going further now, there are a few more technologies which not very famous. Now let's talk about the physical means. The most famous here is UV, guys, ultraviolet. Then we have got gas injection. Ultraviolet, you may have seen it in STP, you may have seen it in drinking water. Okay, to kill the organisms. Then you may have got gas injection, basically gas being injected, ultrasonic, cavitation, heat. So all those physical means to kill the organisms ultimately. But then that would be very rare because they might be not so viable or costly affair. So what normally we see on board ship is either UV or chlorine-based systems, chlorination, electrochlorination, and in some of the cases ozone-based systems. These are the most famous technologies being used. If you have seen anything else, do let me know, we can discuss that as well. So moving on, see the market cap. So market is mostly dominated by UV-based systems, and then come chlorine-based systems. And also approval, if we talk about, these are two systems which have got most approvals, USCG as well as IMO. Okay, now let's specifically talk about UV, ultraviolet. Before, see the UV system also we have got a filter. Now filter size, I told you, if you go below 40 to 50 micron, then there is a challenge of flow rate, or throughput will be reduced, or flow will reduce. What if you are going above 50 micron, guys? What is the problem there? You can write in the chat box what is the problem if you are using a bigger size filter. See, bacteria we can't purify with the filters because bacteria size are already in microns, like very small, few microns only. So bacteria are eventually passing through in any kind of filter. Bigger sediments, yes, we can remove sediments which are bigger in size and already passed your CHS filter. When we already have got killing, when we already have got UV system and chlorine system, you can kill the organisms, then why do we fear about organisms passing through the filter? Because eventually they will be killed, isn't it? Okay, guys, we are near, but the exact answer is money. See, you can kill the organisms with bacteria, with UV light and with chlorine. But if the bigger size organisms are passing through, or more number of organisms are passing through, the intensity that you will be using is way more. And the fuel you will burning in the generator to generate that much power, to generate that much intensity, will be more. Same goes with chlorine. The amount of chlorine used will increase manifold if you are not stopping the bigger organisms in the filter itself. These bigger organisms need high, higher chlorine dosing and higher intensity of the UV. So ultimately, it all boils down to how much money you are investing in the treatment. If you can invest more money, that's up to us. But nobody wants, so people always, companies always wants the best system, most efficient system with less of the consumption, with less of the, you can say, uh, expense that is we have to bear. Okay, so that's an idea here. So you can't go more, you can't go less. So that is an optimum size, 40 to 50 microns. So this is called organic load. We are reducing the organic load in the system by using filtration methods. Okay, moving on. It does also increase your, reduce your sediments and increase the clarity. So UV systems, we need more clear water, so that is an advantage. But the biggest of the advantage is this. Okay, moving on. This is the filter and backwash arrangement. And these nozzles are for cleaning purpose. They can clean the filter. They can use air or water for forcefully cleaning the filter. The pressure, fluid pressure in these nozzles can be 20 bar. Or you may have some sort of some filter, something like this. Now this is similar to your lube oil filter, what you're using for main engine bearings. Even the sizes are same. Your lube oil filter is also around 35 to 50 microns, and your ballast water filter is also 40 to 50 microns. So that means construction shape, size, almost everything is same for these filters. And you have got same differential pressure. So tapping taken from inlet and outlet, and this is the differential pressure switch, which will raise and you can say, which will initiate a backflush if the filter is getting clogged. So the filter is getting clogged, you will get differential pressure, and because of differential pressure, you will have an backflush. Though there is no alarm as such backflush, but if the count of backflush is going higher and higher, and differential pressure doesn't come down even after backflush, then there can be an alarm. Also in the downstream, we have got one pressure transmitter, PT, that will be giving signals to the PLC. So all these mechanisms are fitted. Here this is a motor which is rotating the filters element for backflushing. Okay, this is one of the technology available. Maker is called Optimarine, and this is picture taken from EMA. EMA is Anglo Training Academy in Karjat near Mumbai. So we are having like cadets, engineering cadets and electrical engineers, so being trained there. And those people who are going to sail on a ship having an Optimarine system, they need to do 1 day course on this system, having all this. Because of pandemic, it is not anymore being conducted, but when things become normal again, You will see people start to go for this 1 day course there. Okay, let us see guys, how does it work? Okay, giving you 1 minute to go through this picture. Try and understand yourself first. What are the parts? How should it be working? Okay. Okay, let's discuss guys what is the working. So you'll see that 17 is your inlet. It's coming from pump. And then it goes to filter side, which is number 3. So it goes to the filter and comes out. Filter will be stopping the organism that passed through the C chest filter, and when the differential pressure goes high, it will go to the back flush, and back flush goes overboard. Okay. Now water moves on. It goes to this number 5, which is flow meter, and from flow meter it goes to inlet header. From inlet header, it is now moving towards. So from this header, it actually enters these chambers, and these chambers are called UV chambers. UV, where there is a lamp, 1 lamp per chamber, and then it moves out into the outlet header, and from there on it moves out and goes to the flow control valve. From flow control valve number 7, it moves out and then it goes to either ballast tank or overboard. So it depends where actually it is going to. If it is going to overboard, however, we are not using the filter because there is no use of filter then when it is already going overboard. So you can simply bypass the filter in that case. So what is the sequence then? It is simply going in through this valve. it is just going to the UV lamps. UV lamps will be used in both the case, whether ballasting or deballasting. The reason we will see later, but this is the case. This is how it is. Now there is a adapter for stripping purposes. Let's not focus there. Let's see how exactly working is happening inside. First of all, we must know that what are these valves, 11A and 12. So why is this 11A and 12A are fitted on the inlet header? 12A is your auto venting valve. And for this auto vent valve to work, so basically what it is doing, it is removing air from the system inlet. And for this valve to work, 11A is normally open. Always. Or you can say locked open. Do never close this valve 11A, because this has happened in one of the cases where this is a yard delivery ship, somebody forgot to open this valve. Actually it should be always open. So how it went closed, nobody knows, but it remained closed and auto vent valve was useless then onward, and air could not be taken out from the system. And because air is a bad conductor of heat, UV lamp had air pockets in them and they became overheated and started to burst the UV lamps. One after another, UV lamp was bursting. People could not figure out why it is happening. Then they came to know that this valve 11A is closed. So it should be actually locked open. Otherwise, venting will not happen. So venting is important, guys. Okay. Otherwise, other valves you can see valve number 2, valve number 4, valve number 10, 9, all this. So these valves are remotely operated from a touch screen which is in the ship's office. So no human intervention. Everything can be controlled from the touch screen in the ship's office. You have to basically open few valves overboard, like, or maybe pump suction side. So few of the valves only we need to open manually, otherwise everything is automatically controlled from ship's office. So this is how it works. Now in the UV chamber, there is a UV lamp, and the UV lamp actually needs, so UV lamp has got, each lamp can draw power as high as 35 kilowatt. Now if there are 10 lamps in the system, they have shown 3 here, can be 6, 8, 10, depending upon the capacity. So 35 kilowatt into 10, that makes it 350 kilowatt. So that, and plus ballast water pumps. Okay, so that you can see how much is the power consumption when you are operating. UV system, it's a power intensive technology. You need to start another generator if you are using this. And each lamp, guys, they also need high voltage to generate ultraviolet light. These voltage can run into thousands. It may be around 2000 to 4000 volts. So basically we have to be very much careful while dealing with the system, while working on the system. So if you are working, the cabinet has got a limit switch. The moment you open the cabinet, the limit switch will switch off the power supply to the lamps automatically, so that there is no electrical hazard. Okay, so we have to be careful while dealing with the system. Okay, so how the maintenance is done on these lamps, let's see through a video.
Make sure that the UV power cabinet is electrically isolated. Secure the main switch in off position. Isolate and drain the UV chamber by closing the butterfly valves, and open the drain plug at the bottom of the UV chamber. It is also possible to drain all the UV chambers and manifold by a valve at one of the manifolds. Wait at least 5 minutes before disconnecting the lamp cables in the terminal box or control measure with a high voltage instrument. Remove end caps. Carefully remove the UV lamp. Remove the backing plate. Remove the backup ring and the outer quartz glass O-ring on both ends. Put the installation rod inside the quartz glass to support the glass during removal. Push the quartz glass back and forth by use of the quartz glass extraction tool until it's loose, as the O-ring may stick to the glass. Once the glass, pull it out by the chamber assisted by the installation rod. Replace the inner O-rings and apply lubricant. Clean the quartz glass with isopropanol and non-flossing cloth. Ensure that all stains and marks are removed, and that the quartz glass is in no way damaged. In the event of damage, replace the quartz glass. Install the quartz glass. Reinstall the UV lamp. Make sure the lamp is centered in the chamber.
Guys, so this is quad lamp here. That is basically protecting UV lamp that is inside the quad lamp, quad sleeve. So what happens is that the water is flowing over this, and water will leave some deposits, some yellowish tint on this. Sometimes it is not visible from naked eye. Now this tint is basically what reduces the effectivity of the UV system. So we have got a sensor on top. Here there is a sensor. The sensor is, there are two sensors actually. One is reading temperature transmitter, and another is UV transmitter. Now these sensors over here, basically, they are providing values to the PLC. That what is the intensity of ultraviolet and what is the temperature. Okay. So the UV intensity you will see in the HMI screen, or you can say touch screen. You can see the UV intensity. As I told you, IMO requires it to be more than 100. So not a big deal maintaining 100. But let's say if you are going for heading for US, so there they want it is beyond 600. So this is where the challenge occurs. Normally the value is around 800 to 1000, so that is okay. But if it is coming down, that means that that's a concern. So if it is coming down towards, let's say, 600 or less, although you're still okay to go, but not in US. So the good idea would be to take out the lamp and take out the sleeve and clean this sleeve manually if in situ cleaning arrangement is not provided. How do you clean? First of all, let's carefully take them out. Then you Whether you can see the tint or not, it doesn't matter. Still have to clean it because, as I said, it is normally not visible with the salt deposits and all, scale deposits and all. So you can use either or isopropyl alcohol, or if it is not available to you, you can use vinegar. Okay, so vinegar has been also been very effective, or lime juice. So all this you can use to clean this. After cleaning, put it back, then put back the lamp, and that's it. You are good to go. Okay. But you please be careful that if you are when you are putting this lamp back, the lamp is very delicate here because you can see there is a neck area. You can see, and it's very delicate, and you can, if you doing it for the first time, very likely that you might end up breaking it. More so when there is a cramped up space. Suppose you are in a retrofit arrangement, you are working on a retrofit. Space is already a constraint. This thing issue here, and if you don't have much of the space, and let's say you're doing this thing in the sailing, space is already less, and you're doing in the sailing, ship staff is not enough, and then there's quite likely you end up breaking these lamps. These are very costly lamps, so you have to exercise utmost control while doing so. First of all, if you're doing, don't let the juniors do it without training. First train them, and then only allow them to work upon this. And take proper approval, because you are working on a hazardous system. You have got high voltage hazard. You have got, so these lamps contain mercury vapors, so you have got chemical hazard as well. Okay. So that much. So we be very careful while doing working on the same. Do you have any question you can ask? And if it is clear, guys, this system, please type yes. And let's move on to the PPT. Okay, the wavelength that is normally used is 254 nanometer. This is the most suited wavelength for this purpose. This is one more design. Wärtsilä, wherein all the lamps are in one unit, one chamber only. This is one more design. This is Asia. Some people said that they have done Asia as well. So this is how the layout is. So from sea chest, you are taking first of all to the pump. On pump, guys, it goes to the filter that we know. Pump filter goes to the UV chamber. From UV chamber, it goes to the ballast tank. So this is normally the route during ballasting. Let's see deballasting as well. From ballast tank, it goes to the pump, and bypassing the filter directly goes to UV chamber. This time filter is not used. Then it is going overboard. So this is deballasting. So circuit is very much clear, not a big deal. Moving on. Okay. What we need to understand in the system is your residual effect. That is not there in the system, which is there in your chlorination. So now let's move on to chlorination. So before we discuss chlorination, we need to understand what exactly is residual effect. So you remember in your STP, we are doing residual chlorine test. Why are we doing so? Because some amount of chlorine remains. It is not used up, and this can go into water. Same is the case here. That whatever your chlorine, your, let's say you're dosing up either you're dosing chemical chlorine or what any other means. So these chemicals, they may remain with water over the period of time. Now it serves two purposes. Sometimes it is good, sometimes it is bad. So it is, this residual effect is good in fact initially, because the let's say the water is passing through this chlorinated chamber, or the space which is where the chlorine is being dosed. All the organisms will not get killed suddenly. It may take time for chlorine to work, and when this water is inside the tanks, the chlorine will keep working and keep killing the organisms. Okay, so this is called residual effect. That means when the water is inside the ballast tank, action is still going on. This is not the case with UV, ultraviolet. Guys, in the ultraviolet, whenever the water is passing in from the chamber, only then action is happening. And later on, when the water has gone into the tank, no further UV effect will be seen. So there is hardly any residual effect in UV systems. So that is the reason while deballasting also, remaining organisms what remain during ballasting, they will be easily get killed in deballasting cycle. So we have to use UV both the cycles, both the times. However, because of residual effect, you don't have to dose chlorine again during deballasting. Whatever you have dosed during ballasting is enough. So much so that excess of chlorine remains during ballasting. So we are concerned about this excess chlorine, which is basically we call as TRO, total residual oxidant. So during deballasting, we are focusing and we are not letting excess of chlorine go into the water. Because of local regulation, we cannot dump chlorine into the waters. Otherwise, we can be penalized. So countries have put restrictions. Okay, you can put chlorine, but not beyond certain value. And usually that value is 0.1 ppm. So anything beyond 0.1 is not allowed, guys. Now you remember the same value for sewage treatment plant STP was, maximum value was 0.5, but here the maximum value is 0.1 itself, not beyond that. And the reason being the quantity. In STP we are hardly dumping anything. In your ballast, even your 0.1 with huge quantity of water being dumped can be disastrous. Okay, so this is the idea why we are limiting the value to 0.1 in this case. So I hope you understood the residual effect. Now there is one more parameter here, that is called holding time. Now for chlorine to work, you must have certain holding time in the tank. Okay, we cannot say that okay, you just have ballast in the tank after 1 hour. Okay, now let's deballast. But you do not have that holding time actually, because certain holding time is required for it to fully show its effect, kill the organisms. And minimum certain states, they require certain holding time. For example, 24 hours. Most of the like state, they need, what state they need to have a holding time of at least 24 hours for the effect to have taken place. But normally we know that this much of holding time usually happens. Okay, so that much okay, we can, not a big deal. Okay, so chlorination, how does it work? We need to see that, and what way we are dosing. So guys, there are two ways of chlorine dosing. One is you directly dose chlorine-based chemicals. Second method is you generate chlorine-based chemicals. So first is dose directly chlorine-based chemicals. So where will the chlorine-based chemical will be there? We usually take these solids, chlorine, liquid chlorine, and that same with you're using for STP. Similar to that, you will be using chemical here as well. It may be in powdered form or it may be in liquid form. So that you are dosing into water, or you can make use of seawater to generate these chemicals, because we know seawater contains chlorine in that. Okay, let's see guys one by one these technologies. Okay, this is one such system where we are dosing chemical chlorine. This is GFE. Some of you may have said it on the system. So how exactly it is working, let's see this. You are taking water from ballast tank, or sorry, from the sea chest. Then it goes to ballast pump. It goes to filter number 5, and from then onwards it is moving further. So dosing is happening over here. We are dosing chemical chlorine in this passage, and that can be taken. The chlorine can be, you can have your granular or liquid. Okay, and when the chlorine has been dosed now, what moves on? To the tank. Like this. So this is your ballast tank, and this is your ballasting cycle. Now, whether you are dosing the correct value, because it depends on the flow rate of water. Sometimes you need more flow rate, sometimes you need have lesser flow rate. So basis that, and basis the draft level flow rate changes, and also dosing rates must change. So for that we need to have a feedback mechanism. This is there, number 19. So it is taking a feedback, giving it to the PLC, which is deciding upon how much dosing rate should be maintained. So this is all ballasting cycle is. Now let's move on to deballasting. So during deballasting, guys, suction is taken from same tank. And goes to the ballast pump, and from there it goes overboard. But as I said, you cannot dump large amount of chlorine into the waters. So you are measuring residual oxidant. Chlorine is an oxidant, by the way. So you are measuring total residual oxidant, or you can say chlorine, residual chlorine, while pumping out. So who is measuring that? This number 20 is a sensor fitted. It will be taking up the values for PLC. So it is measuring the TRO. If it is more than 0.1, you have to increase the neutralization. Where exactly it is being neutralized? Here. It is coming from this neutralization section. So this neutralization section is neutralizing this water. So this is the feedback from sensor. You are modulating or changing the flow rate of the neutralizing chemical. And what neutralizing chemicals is used normally? So first of all, if it is an oxidant which you are neutralizing, so you must be using some kind of reducing agent. Because oxidizing agent can be killed by reducing agent. Okay, so usually you are using sodium thiosulfate as a neutralizing agent. Yes, that's right. So you are using this chemical here, sodium thiosulfate, and it is being dosed into the water. And that flow rate can be changed as per the water going out. If it is more, that you dose more. If the TRO is more, you dose more. If TRO is less, you can reduce the dosing rate. This is all about your GMP plant. Hope the things are clear. Moving on, guys. Okay, this was all about chemical chlorination. Gentlemen, if we talk about the various technologies, see, first of all, in your STP also you are dosing some chlorine. So sometimes you see chlorine being dosed as solid, sometimes it's a liquid, sometimes it's a gas. So why is it so? Gas normally you will not see on board ship, but guys, gas can also be dosed. Chlorine gas can be also can be dosed, especially in swimming pools, uh, shore-based swimming pools. We are having chlorine dosed in form of gas in the pipelines. Okay. Actually speaking, chlorine is actually a gas. Chlorine is a gas itself. It's not solid, it's not liquid. So when we say are you dosing chlorine, actually we are wrong in saying that. It's a chlorine compound. It's a chemical having chlorine in it. It's not pure chlorine. Pure chlorine is a gas. It can also be used, but because of other challenges, we are not using it. Where will we store it and other problems? It's not good for health also. So we are not actually using gaseous chlorine. We either are using liquid or solid. So guys, if you are using liquid, if you are using solid, then basically the chemical composition of the base substance will be different. So in liquid form is basically sodium hypochlorite is basically used, and this is liquid. When you talk about solid, it is basically calcium hypochlorite is being used. Okay. So these are the basic chemicals that we are using in industry, especially the lower, but 2 and 3. We are using on board ship. Solids can be or thiocyanuric acid also, or calcium hypochlorite also. This is what we are using on ships. Somebody's mic is on. Any question? Okay. But how do they work? See, ultimately, any of the chlorine you are dosing, whether you are dosing as a chemical or you are generating chlorine or in electrochlorination by passing electrical current. So any of this chlorine ultimately are using these dangerous ions. One is your OCl ion, and secondly the acid which is called HOCl, hypochlorous acid and hypochlorite ions. And some cases hydroxide also. But that is not that is for electrochlorination purposes. The first two, OCl minus and HOCl, these are the basically the chemicals that are killing the organisms because they will attach to the proteins on the cell membrane and inside, and will basically change the protein qualitatively, it will damage the protein and organisms dies. This is how it works. Okay. So hope this part is understood. So let's now move on to electrochlorination. How do we generate chlorine with the help of electrical current? Okay, guys. So in ECU, electrochlorination unit, we are having these DC plates. So ultimately what we are doing here is, let's say tech cross. Some of you must have sailed with tech cross. Somebody was writing in the chat box. So electrochlorination, what are we doing there? We are passing electrical currents in the seawater. And seawater is a good conductor. So this electrical current is a DC current. On chip we are making AC. So AC first will be converted to DC with huge rectifier units, and the current value is also very high, easily more than 300 amps. But the voltage level is very low. You can see the voltage level and see the current level. So this is depends. So there it is. They are showing you running into thousands. Current is more than 2000. So it's 2500 amps, which is very, very high amount of current. Though voltage is very low, so it is not risky for us because we should be worried of voltage, not current as such. So maybe you will not get a shock, but organisms can. Organisms can, and killing is basically happening because of three reasons why killing is happening. First, it's a current. It will electrocute. Okay, it will electrocute the organisms. Secondly, it will cause heating effect, and because of that, organisms inside of organisms heat will generate and will kill the organisms. But the third one, which is most important here, which is the major reason of killing the organisms, is generation of OCl minus. OCl minus and HOCl and OH minus. These are generated during the electrolysis of water or seawater, to be more precise. So guys, seawater normally will contain NaCl. We know that seawater is salty, isn't it? So 95% of the salt is NaCl. So Cl is already there. But this is not the form where we want. We want it in some other form. So we are passing electrical current and generating what we want to kill the organisms. To better understand this, let us see a video.
This video is for providing an operation and installation for the Electro-Clean system, the ballast water management system developed by TechRoss. ECS is one of the most effective disinfection systems using electrolysis. ECS treats one time at ballasting with certainty using a simple composition of equipment: ECU, ANU, PDE, TSU. ECU is the main equipment for disinfection of ballast water. ANU is designed to neutralize any remaining residual TRO prior to discharge. It is used during deballasting and stripping only. PDE supplies the necessary current to the chamber after converting 440 volts AC to DC, depending upon the salinity of the water, enabling operational controls and facilitating ECS electrolysis. TSU measures TRO concentrations during ballasting and deballasting to maintain the proper TRO concentration levels for efficacy disinfection and neutralization. FMU is installed in between the ballast pump and the inlet of ECU. It monitors operation of the ballast pumps and assists in the proper functioning of ECS during ballasting. T-strainer helps to protect ECU from large sediment, ensuring effective and efficient operation of ECS. As the ballast water flows in the vessel, ECU is receiving the required current and voltage from the rectifier, enabling them to electrolyze the ballast water and kill microorganisms by electrochemical actions. The electric energy and the production of oxidants such as hydroxyl radical and hypobromite, which can oxidize cell membranes and cell walls to disinfect organisms. After After treatment, the treated ballast water is stored in the ballast tank during the voyage. During this period, TRO, the residual hypochlorite, remains active in the ballast tank, preventing any regrowth of microorganisms for up to 30 days after treatment. ECS does not need to retreat during deballasting. Before discharging the treated ballast water from the ballast tank, TCU examines the TRO concentration. ANU doses sodium thiosulfate to reduce TRO value down to 0.1 ppm before discharge. The neutralized water no more needs to treat. TechPros provides various installation solutions for each project, needs of the shipyards and the ship owners. This is one of the general installation references on tanker. If there is no pump room but submerged ballast pump, you can make safety room on deck.
Okay, that was it. So guys, I hope you understood the concept of electrochlorination, how it is affected. If you have understood, just say yes, and we can move on with another topic. Guys, if we compare between these three technologies, yeah. So if we compare between these three available technologies, guys, we will see that there are some shortcomings during usage. This one is a UV here. This is a chemical chlorination, this is electrochlorination. Now salinity, will the salinity affect ultraviolet? No, it will not affect. So by salinity case is not applicable in UV, so it is passing. Turbidity, does it affect UV? Yes, it does. However, the other will pass in this case. Turbidity will not affect chlorination in any sort. So chlorination will still work in turbid water. Do we have any residual effect in UV? No, but we do have an electrochlorination and chlorination a residual effect. Active substance is used in. So do we use any active substance? Yes, we are using in chlorination and electrochlorination for neutralization as well in chlorination. But there is no active substance being used in your UV. So let's see again salinity. Your chlorination will also pass the salinity test because you are dosing chlorine from outside. However, ECU or electrochlorination will fail because if the water is not saline, if it is a fresh water, there is no chlorine present. So in that case, system will fail. Agree yes or no, guys? Agree? If there is a fresh water or brackish water, then your ECU, then your TechPro system is not working fine with that. For that reason, you may have to carry some fresh seawater in one of the ballast tanks for this purpose. Residual effect. So
It's not
it's
here.
not here.
Active
Active
substance is
substance
being
is being
used
used
in those
in those
cases.
cases.
Consumables. We
Consumables,
have
we
got
have got
consumables in
consumables
all
in
of
all
them.
of them.
So some
So
amount
some
of
amount
money
of
has
money
to be
has to be
invested in
invested in
consumables.
consumables.
Hazard,
Hazard,
all
all
three
three
fail.
fail, some of them.
Some
Some
hazards will be
hazards will
there
be
in
there
all
in
three.
all three.
Okay.
Okay,
Market
market
capture is
capture is
UVs
UVs
50%
50%
market
market
capture.
capture.
Electrochlorination
Electrochlorination
35%.
35%.
Remaining
Remaining
others.
others.
Okay,
Okay,
for
US for
USCG
USCG
compliance, we have
compliance, we
already
have already
discussed that.
discussed that.
For
For
USCG
USCG
guys,
guys,
certifications
certifications
required.
required.
Additionally, you may
Additionally, you may
require
require
or
or
AMS
AMS
alternate
alternate
management
management
system,
system,
wherein
wherein
your
your
USCG
USCG
approval is
approval is
needed for
needed
some
for some
equipment.
equipment.
If
If
USCG
USCG
approval is
approval
not
is
there,
not there,
at
at
least
least
some
some
alternate
alternate
arrangement is
arrangement is
made
made
for some
for
time
some
being,
time being,
so
so
that
that
you can
you
still
can still
carry
carry
out,
out,
you can
you
still
can still
use that
use that
system in
system in
US
US
waters.
waters.
Secondly, I've
Secondly, I've
already
already
discussed
discussed
that
that
every year,
every year,
as
as
per
per
NKDS,
NKDS,
BGP,
BGP,
every year
every year
calibration is
calibration is
mandatory
mandatory
for the
for the
sensors.
sensors.
Then you need
Then you
type
need type
approval
approval
certificate,
certificate.
then you
Then
need
you need
plan,
plan.
you need
You need
certification, you
certification.
need
You
a
need a
ballast water
ballast water
record book.
record book.
So these
So
are
these are
common for
common for
all of them.
all of them.
Okay. If you
If you
don't
don't
comply with
comply with
USCG,
USCG,
there are
there are
fines.
fines.
So these
So
are
these are
certificate
certificate
guys.
guys.
You can take
You
a
can take a
snap.
snap.
Your
Your
record
record
book,
book,
as
as
I
I
said,
said,
your
your
plan,
plan,
certificate,
certificate,
type
type
approval
approval
certificate,
certificate,
USCG
USCG
approval
approval
certificate,
certificate,
alternate
alternate
management
management
system.
system.
The
The
VGP is
VGP is
required,
required,
vessel
this is
journal
journal
permit,
permit,
and
and
sure
sure
lab
lab
analysis
analysis
report.
report.
Calibration
Calibration
of
of
sensors.
sensors.
So
So
these two
these two
are as
are
part
as
of the
part of the
VGP.
VGP.
Okay.
Okay.
Holding
Holding
time
time
we
we
have
have
discussed.
discussed.
Fines
Fines
you
you
can
can
see
see in
US
US
waters,
waters,
$28,175
$28,175
if you do
if you
not
do not
comply.
comply.
Challenges
Challenges can be many, can be.
let's
So
go
just let's
one by
go
one.
one by one.
Filter
Filter
clogging.
clogging.
So
So
these are
these are
written
written
down
down
basis the
basis the
feedback from
feedback from
candidates like
candidates
you.
like you.
So some
So
people
some people
face the
face
high
the high
DP,
DP,
frequent
frequent
clogging of
clogging of
filters,
filters,
valve getting
valve getting
stuck,
stuck,
valve
valve
crack,
crack,
UV lamp
UV lamp
busting,
busting,
intensity not
intensity not
proper,
proper,
water
water
hammering,
hammering,
stripping
stripping
related
related
issues,
issues,
sampling
sampling
issues,
issues,
TRO value
TRO
not
value
coming
not
up,
coming up,
TRO
TRO
values not
values not
matching with the
matching with the
portable
portable
units,
units,
solenoid valve
solenoid valve
malfunctions,
malfunctions,
ANU
ANU
auto
auto
dosing not
dosing not
lowering the
lowering the
TRO.
TRO.
So
So
yes,
yes,
problems can
problems
be
can
many
be many,
guys.
guys.
Now
Now
it
it
depends on
depends on
case
case
to
to
basis
case
how
basis
you're
how
going
you're
to deal
gonna
with the
deal with the
situation.
situation.
So
So
don't think
don't
that
think that
you will
you will
surely face
surely
this
face
problem.
problem.
I've said
I've
with
said
one of
with
the
one of the
systems,
systems,
uh,
uh,
few
few
problems we
problems we
faced that
faced
were
that
UV
were
lamps
UV
were
lamps were
actually
actually
there was a
there was a
spring
spring
inside the
inside
UV
the
lamp
UV
and it
lamp
was
and it was
twisting
twisting
and
and
it
it
was
was
breaking
breaking
the
the
UV
UV
lamps.
lamps.
So that
So
was the
that was the
problem because
problem
of
because of
vibration.
vibration.
Later on
Later on they
they
changed the
changed the
design.
design. The
The
spring
spring
direction
direction
was
was
slightly
slightly
modified,
modified,
coiling
coiling
direction,
direction,
and
and
that's it.
that's
The
it. The
problem was
problem was
solved.
solved.
The rest other
Rest other
problem that we
problem that we
faced
faced
was
was
uh,
uh,
that
that
system will
system
never
will never
work
work
in
in
muddy
muddy
waters.
waters.
But we
But
could
we could
do
do
hardly
hardly
anything
anything
about that.
about that.
Okay.
Okay.
So if the
So if the
water is
water
muddy,
is
what
muddy,
can you
what
do?
can
You
you do?
don't
You
have
don't have
any other
any other
choice.
choice.
So then you
So then
have to
you
go
have to
for
go for
contingency.
contingency.
Memory
Memory
card.
card.
PLC
PLC
has
has
got
got
a
a
memory
memory
card,
card,
guys.
guys. Uh,
So please
so please
remember this
remember
memory
this memory
card
card
can
can so
memory can
memory can
hold
hold
till
till
24
24
months.
months.
That is
That
2
is two
years.
years.
2 years
Two
of
years of
memory.
memory.
And
And In the touch screen panel, you
can't
can't
delete
delete
the
the
previous
previous
memory.
memory.
So
So
whatever is
whatever is
recorded, it
recorded,
will
it
be
will be
remaining
remaining
for the
for the
next two
next
years.
2 years.
Even the
Even
flow
the flow
rates,
rates,
UV
UV
intensity.
intensity.
So even
So
if you are
even if you are
cheating the
cheating the
system
system
somehow,
somehow,
records are
records are
available.
available.
Tomorrow you
Tomorrow
can
you
get
can
caught.
get caught.
So
So let's not.
let's be
Let's
more
be more
transparent.
transparent.
If at
If at
all
all
some
some
problem is
problem
there,
is there,
so you
so
have to
you have to
inform.
inform.
And this is the
And this is the
problem
problem.
instead of
Instead of
brushing it
brushing
under
it
the
under the
carpet.
carpet.
Okay.
Okay.
These are
These
some of
are
the
some of the
ports where
ports
we have
where we
seen
have seen
water issues
water
are
issues
there,
are there,
water
water
quality,
quality,
filter
filter
clogging very
clogging very
frequently,
frequently,
muddy
muddy
waters.
waters,
Especially the
especially
river
the river
passages.
passages.
Audit
Audit
findings.
findings.
Calibration
Calibration
of
of
flow meter
flow meter
on
on
yearly
yearly
basis was
basis was
mentioned in the
mentioned in the
manual.
manual.
However, it was
However, it
not
was not
included in the
included in the
PMS.
PMS.
So as I
So as
said
I said
earlier to
earlier to
you,
you,
manual
manual
and
and
PMS must be
PMS must be
matching.
matching.
Please
Please
check
check
the
the
PMS when you
PMS
go
when
on
you go
board.
on board.
Because
Because
tomorrow there
tomorrow
can
there
be
can
an
be an
issue with
issue
that.
with that.
Okay.
Okay.
So
So
let's now
let's
go
now
to the
go to the
question
question
answers.
answers.
Please answer
Please
question
answer
number
question
one,
number one,
guys.
guys.
Okay,
Okay, very good.
Yes, that's
Yes,
right.
that's right.
Yes, very
Yes,
right.
very right.
They
They
are
are
independent.
independent.
Moving
Moving
on.
on.
Third
Third
is
is
That is the full.
absolutely
absolutely
right.
right.
Was
Was
run in
run in
both
both
the
the
times.
times.
Fourth,
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 because
because
it
it
does
does
have
have
residual
residual
effect.
effect.
Fifth,
Fifth,
okay, very right.
very
It
right.
should
It should
not be
not be
more than
more
point
than
one.
point one.
Okay,
Okay.
so
So
that is
that is
correct,
correct,
guys.
guys.
Do we have
Do
any
you have
other
any other
question? No.
question? No.
So with
So with
that,
that, we have
we
come
have
to
come
an
to
end
an
of
end
the
of the session
session
here.
here.
Finished in
Finished in
time.
time.
And
And
would
would
request you to
request
switch
you to
on the
switch on the
videos.
videos.